Okay. More. Writing logs in terms of others is where I'm going to start. Right, okay, and so it's not particularly cloudy, but my eyes are doing that thing again. The light on, otherwise they will hurt. And that's fine. Okay. So, and may need a calculator for this. Writing logarithms in terms of others. So, let's begin. Use the properties of logarithms and the values below to find the logarithm indicated. Do not use a calculator to evaluate the logs. Right, so just try to understand this first. Okay, so we're told log 12, 8, and 7 are these respectively. And then we're asked to find the log, common log, of 7 over 8, it appears. Yes, the common logarithm, which is logarithm base 10. Okay, well, that would be log 7 take log 8. That's equivalent to log of 7 over 8. And so according to this, 0.8 take 0.9, which is negative 0.1. And indeed, 7 over 8 is between 0 and 1, and therefore we would expect it to be negative. But I need to check just to make sure that I'm on the right track for these. Okay, so there's 24 in total. Right, okay. So totally fine for that one. Right, okay. So this would be strange. That would be log well, I'll rewrite it up here. I'm not very used to this. Okay, so 8 over 12 is equivalent to 2 over 3. So I'm going to say that this is the same as log of 8 over 12, which is thus log 8. Take log 12, which given the figures here is 0.9. Take 1.1, which is exactly equal to negative 0.2. Here, log of 64. Now 64 is 8 squared, and thus this is actually equivalent to the log of 8 squared. And the power law of logarithms means that I can move that 2 to the front. So it's 2 times log of 8, which using the approximate figures here is 2 times 0.9, which is exactly 1.8. Log of 96, well, 96 is 12 times 8. So this is the logarithm of 8 12s, which is log 8 at log 12, which is, by the approximate figures here, 0.9 plus 1.1, which is exactly 2.0. Of course, the whole thing is as long as you have an approximate equals to at any point, the whole thing finishes with an approximation. And of course, log of 1 over 64. Now 8 to the negative 2 is 1 over 64. So that's equivalent, which is equivalent to this. Which is approximately -2 times 0.9, which is exactly -1.8. The seventh, that's 7 to the -1, and therefore it's just the negative of that. So there's some welding going on in the background, which produces a very unpleasant sound indeed. I'm just going to close that. And then we must check and make sure that these are correct, the first 6. -0.1, that's in agreement, and that's in agreement as well. Okay, good. Now the next 6. So here we're working in log base 3, not the common logarithm anymore. And we have to create 330. So that we know is what actually is that? Well, it's 3 times 110, which is 3 times 10 times 11. So that's log base 3 of 3 plus log base 3 of 10 plus log base 3 of 11. And log base 3 of 3 is 1. That by the given figures, so approximately equals 2 here, please. By the given figures is 2.1, and that there is 2.2, which is 5.3. And next, log base 8 of 81 over 7, well, that's 9 squared. So log base 8 of 9 squared over 7 is 2 log base 8 of 9, take log base 8 of 7, which is approximately equal to 2 times 1.1, take 0.9. 2.2 take 0.9 is 1.3. Next, log base 5 of 264, which is 132. Wait, no, it's 4 times 66. So the product of all of these, log base 5 of 4 times 6 times 11, which is log base 4. Log base 5 of 4 plus log base 5 of 6 plus log base 5 of 11. By the approximate figures is 0.9 plus 1.1 plus 1.5, which is 3.5. And here 486, well, that's 243. And 9 and 243 are both powers of 3, so we're going to use that. In fact, it's 81 times 6. That's much better. So we'll just say log base 9 of 81 times 6. No, I don't know why I did it down there. It's correct then. Okay, so log base 9 of 81 times 6, which is, come on, log base 9 of 81 plus log base 9 of 6, which by the approximate figures, log base 9 of 81 is exactly 2, and log base 9 of 6 is approximately 0.8. And so the final answer is 2.8. Next up, log base 6 of 3 over 50. So, how to do this? Oh, double the top and bottom. That's log base 6 of 6 over 100, which is log base 6 of 6. Take log base 6 of 100, which by the approximate figures, I'm just going to skip, is 1. Take away 2 times log base 6 of 10. So in other words, that is 2.6, and 1 take 2.6 is negative 1.6. Next up, we've got log base 6 of 800, and that's obviously 8 times 10 squared. So log base 8 plus 2. They should be base 6. Incorrect. Yeah, okay. So log base 6 of 8 plus 2 times log base 6 of 10. And by the approximate figures, that's 1.2 plus 2 times 1.3. So 2.6 of 1.2, which is 3.8. All right, now to check. 7 and 8, correct. 9 and 10, correct. 11 and 12, correct. Excellent. Okay, the common logarithm now of 6, 9, and 4 is given as a, b, and c respectively, and we need to create the common logarithm of 1/16. So 1/16 is 4 to the negative 2. Log, just like that, which is negative 2 log 4, which is negative 2c. Log base 4 of 7, 6, and 9 is r, s, and t respectively, so find log base 4 of 24. And 6 times 4. Well, 24 is 6 times 4. So we can say log base 4 of that, which is log base 4 of 6, s, plus log base 4 of 4, 1. Next, log base 5 of 12, 9, and 11 is r, s, and t respectively, so find log base 5 of 1/12. Well, that's 12 to the negative 1. So in other words, the negative of log base 5 of 12, which is negative r. Here, 4 to the minus 2 is 1 over 16. So this is log base 9 of 4 to the minus 2, which is minus 2 lots of log base 9 of 4, which is minus 2b. 729. Well, 729 is 9 cubed, so it's 3 times log base 8 of 9, so 3b. 392. I have a feeling that's 7 times 48. 7 times 48. No, it's not. 392 is 196. Oh, well, that's 14 squared, isn't it? So just factorize it. 14 squared times 2, so 2 cubed. No, 2 to the 5. And 7 squared, like that. Wrong. Wrong. 2 times 7 times 2 times 7. Then times 2. So 2 cubed times 7 squared. Better. Okay, so that's log base 7 of 8, which we already know is s, plus 2. It's s plus 2. And that's the next 6 done. So we need to check now. -2 through s plus 1. That's all correct. That's all good. Excellent. All right, log base 6 of 1/9. Well, use 4. So it's like log base 6 of 4 over 36, which is log base 6 of 4. Take log base 6 of 36. Log base 6 of 4 is z, or z, and log base 6 of 36 is 2. So z take 2. 729 is 9 cubed. So this is just going to be 3b. 1 over 270. Okay, so 6 times 9 is 54, and then times that by 5, and you get 270. And so it's log base 5 of 5 times 6 times 4, which is 1 plus p plus q. Next up, 5 over 256. So let's turn that into log base 8 of 10. Take log base 8 of 512. And 8 of 512. Well, that's 8 times 8. No, it's 8 cubed. Sorry, beg your pardon. It's 8 cubed. So it's going to be P, take away 3. Next one here. Okay, so double the top and bottom. So log base 30, take log base 7 of 30, take log base 7 of 64. So that is yeah, that's x plus z. Take away 2y, like that. And now this one. So like maybe triple the denominator. Triple the numerator and denominator. So 96 over... No, wrong. 96 over 81. Log base 8 of 96. Take log base 8 of 81. So it's log base 8 of 96. Take away 2r. Log base 8 of 96, well, that's 8 times 12. So that's 1 plus p. Take 2r. Okay, and now to check. 17. We've got 3b, 5 at 2, that's, s at 2, that's correct. Z take 2, 3b, that's correct. How unfortunate. Correct this. So, minus. It should all be negative. P take 3 is correct. Z at x take 2y is correct. And 1 at p at 1 take 2r. That's correct. Okay, all good. All good. And now to solve some logarithmic equations. All right, so 26 here to do. Okay, so just start out by raising 10 to the power of both sides, because don't forget there's an invisible 10 down there. And then 5x is equal to 2x at 9, which tells me that x is 3. Okay, there's 26 to do, so I'm going to check after the first 4 to see if that's right. 10 take 4x equals 10 take 3x. So negative 4x is negative 3x, so x is 0. 4p take 2. I mean, these are just, really, these are just solving linears. Are they not? So 9p take 2. 9p is 7, so p is 7 over 9. 4k take 5. 2k take 1. So 2k is 4k. So 2k is 4, so k is 4 over 2, which is 2. And now to check. Okay, 3 on the plus, 0. 7 over 9, 2. All right, so we're doing good so far. Minus 2a add 9 equals 7 take 4a. So 2a add 9 equals 7. So 2a equals minus 2. So a is negative 1. And now what about the next one? Okay, so I guess that's that. That's what that means. So if 2 times log base 7 of negative 2r is 0, well, then that means that log base 7 of negative 2r is 0 as well. Now, remember that this is sort of like asking a question. To what power do I have to raise 7 in order to get negative 2r? And if the answer is 0, then negative 2r must be 7 to the 0, so it must be 1. And if that's the case, then r itself is negative 1/2. Okay, next, add 10 to both sides. So log base 3 of n add 3 or you can take off the negative 10 from both sides, however you want to see it, is 0. So 3 to the power of 0 is n add 3, so 1 is n add 3. So n must be negative 2. Here, we're going to start by dividing both sides by negative 2. So log base 5 of 7x is negative 1. And it says, as a reminder, to what power do I have to raise 5 to get negative 1? And to what power do I have to raise 5 in order to get 7x? And the answer is negative 1. Therefore, 5 to the negative 1 is 7x. Therefore, 7x is simply a fifth. And so x itself must be 7 over 5. And now to check this next 4. So we've got negative 1, negative 1/2, that's all good. Negative 2, and no, that's actually wrong. Darn it. I didn't divide by 7 correctly. Unbelievable. Arithmetic errors. Sometimes they creep in. But other than that, basically okay. Right now, the next 4. So it says that log of negative m plus 2 equals 4. Okay, so log of negative m is 2. And there's a secret 10 down there, like that. So to what power do I have to raise 10 to get negative m? The answer is 2. So you just rewrite it like that. And so if 100 is equal to negative m, that means that m is negative 100. Okay. For this one, start by dividing both sides by negative 6. So we have 4 on the right. So log base 3 of x take 3 is 4. And now what? Well, now it's saying that if you want x take 3, do 3 to the 4. And 3 to the 4 is 81. So x take 3 is 81, so x must be 84. Now we have log base 12 on both sides. So do 12 to the power of both sides. So v squared at 35 equals negative 12v, take 1. So turn it into a quadratic, move everything to one side to set it equal to 0. So v squared at 12v at 36 is equal to 0. And what pair of numbers multiply to give 36 and add together to give 12? Wait, are there any numbers? Don't think so. Am I messing this up? 2 and 18 don't work. 3 and 12 don't work. 4 and 9. Oh, 6. Of course. 6. Okay. So v at 6. Square it. And you'll get 0. And what that means is that v must be negative 6. Okay, next. 9 to the power of both sides. So same story. Negative 11x plus 2 equals x squared at 30. Make it a quadratic. So x squared at 11x plus 28 equals 0. And in this case, I know that x at 7 times x plus 4 equals 0. Quick thing about this. You know, log of like a negative number doesn't logically make sense. So just check, you know. Okay, minus 100, that's fine. 84 take 3, that's fine. 6 squared at the negative 6 squared, all at 35. And then over here, yes, that's fine as well. Okay, here the claim is that x is negative 7 or 4, or negative 4. But we must check. Okay, for negative 4, it's totally fine. For negative 7, it's totally fine. Okay, so now to check. Yes, these are all fine. Okay, now the next 4. Remove the logs from both sides. So 16 add 2b equals b squared take 4b. Make into a quadratic. So b squared minus 6b minus 16 equals 0. And the way to get this is to do b take 8 times b add 2. And this tells us that b is either 8 or negative 2, but we must check to see if that makes sense. So 16 at 2 times 8 on the left, that's absolutely fine. 64 take 32 on the right, that's fine. 16 take 4 on the left, that's fine. 4 plus 8 on the right, that's fine. Natural logarithms of both sides. That's what this is saying. And to remind you, ln of whatever is actually just log base e of whatever. These mean the same thing. And e is that superstar number in mathematics, second only to pi in terms of famousness. And it's about 2.718. And you know, explanations vary, but we can look at it later. But one of my favorite ones is that it's like 1 plus 1 over n to the power of n, as you let n shoot off as far as you like to infinity. Anyway, e to the power of both sides. That's how you do it. So you remove the logarithms. So n squared at 12 equals negative 9n, take 2. Move that over, so n squared at 9n at 14 equals 0. So n at 2 times n at 7 equals 0. So n is equal to negative 2 or negative 7. Make sure it makes sense. Stick in negative 2. Totally fine. Stick in negative 7. Totally fine. Log of x plus log of 8 is equal to 2. Well, by the laws of logs, that means log of 8x is equal to 2. Then do 10 to the power of the left-hand side equals 10 to the power of the right-hand side. And if I do 10 to the power of the left-hand side, it just turns back into regular 8x. But 10 to the power of the right-hand side turns into 100. And if 8x is equal to 100, that means that x itself is 10.5 or 12.5 or 12.5. Here, log of x take log of 2 equals 1. So by the laws of logs, log of x over 2 equals 1. 10 to the power of both sides, so x over 2 equals 10. So x is equal to 20. And now to check. 13th is fine. 14th is fine. 15th also good. And 16th is good as well. Next four, please. You got it. This would be log of 2x equals 1. Bringing them together. 10 to the power of both sides. So 2x is 10. So x is 5. Log of 7x is log of 37, you say. Well, that means that 7x is 37. So x is 37 over 7, which is like 5 2/7. For this one here, log base 8 of 2 is negative 1/3. Because 8 to the negative 1/3 is 1 over 8 to the 3rd, which is 1 over the cube root of 8, which is 1 over 2. Wait, did I get that right? Am I getting this right? Oh, beg your pardon. No. That's just a 1/3 itself. I didn't have to do the negative. That's just a 1/3. Okay. So I'm going to take that away from both sides. So I'm just going to have log base 8 of 4x squared equals 2/3. And then I'm going to do 8 to the power of both sides. So I'm going to have 4x squared on the left. Now, what is 8 to the 2/3? Well, that's 8 to the 3rd to the 2, which is 4. So 4 there. So this means x squared is 1. So x is what? Minus 1 or plus 1. So that makes sense when I stick it in. That's totally fine. Right, now this one. Okay, so it's like division. So log base 9 of x add 6 all over x equals log base 9 of 2. Raise 9 to the power of both sides, so x add 6 over x equals 2. Times both sides by x, so x add 6 is 2x. And then that means that x must be just like 6 itself. All right, now to check. 17 agreed. 19 and 20, yeah, it's all agreed. Okay, now for this one here. Six to the both sides, move that x over. So one is 28x, so x must be 1 over 28. Combine them. You know what? I have such horrendous nausea at the moment, and I do not know why. And what really makes me nauseous is thinking about like artificial flavorings. But anyway, so x squared is 4. 2 or minus 2 seems to work just fine. Learn, also known as the natural logarithm. That is an L followed by an N. Okay. There. E to the both sides, please. So 2 over 3x at 2 is E. So that means 2 is E, and then open some brackets here, 3x at 2 like that. But we have to get x by itself. So 3ex plus 2e, take 2e. So 2 take 2e, like that. Divide both sides by 3e. 2 take 2e over 3e. Which I guess is, yeah, I'm fine with that. That's absolutely fine. Okay. Learn now of negative 3x take 1 over 7 equals, wrong, 2. E to the both sides now, so e squared on the right, then bring that 7 up, so minus 3x take 1 equals 7 e squared. Add the 1 and divide by 3. No, add the 1 and divide by negative 3. 7e squared add 1 divided by negative 3. Right, now to check. And these I'm more suspicious of. I don't know what the difference between saying it those ways is. I'm suspect of x, I'm suspicious of x, I don't know, but I need to find out. So anyway, 2 or minus 2, that's an agreement, and that's also an agreement, but they put the negative on top. Fine. X take 3 over x take 5 equals ln of 5. E to the both sides to get rid of the logarithm, the natural logarithm. So x take 3 equals 5 of x take 5, just like that. And now this is just a linear, so 4x on the right, negative 25, so add it on. So what's negative 3? Add 25, so that's 22. So that means that x is 11 over 2. And then here, all right, look, 4x plus 1 over 3 equals 5. So 4x plus 1 equals 3e to the 5. So x equals -1 plus 3e to the 5 all over 4. And that's all correct. Hoorah. Okay, let's say this. Now to try inverses of logarithms. Okay. Right, 24 questions. Let's get started. Find the inverse of each given function and to take a small sip of water. And now to get started, you know what? Really stuffy. Stuffy the Vampire Slayer. Now, if y equals the log of -2x, then what I think they mean, well, okay, just follow the usual procedure. So just do 10 to the y equals -2x, divide both sides by -2, and then we get that y is equal to the negative of 10 to the y, all divided by 2. And now try the same thing for this here. So do like a quarter to the power of both sides. So a quarter to the y equals x to the 5, which means that, I'm sorry, this is just bizarre. Okay. Which means that the fifth root of a quarter to the power of y like that. There. Okay, strange. Okay, I don't know if this -4 is in the argument or not. This is why I don't like it when they do it. No, they don't do brackets. But over here I can see that it's actually fine. All right. So y at 4 is log base a fifth of x. Now 1/5 to the power of both sides, and that should get x by itself. And so now we just swap the variables. So 1/5 all to the y at 4. Just like that. 3 to the y. All right, okay. Log base. Now log base 4 of both sides to get the x back by itself. Log base 4. Like that. All right, now to see if this is actually correct. Okay, first one's fine. Next one, 1 over the 5th root of 4 to the x. Sure, I mean, that's logically equivalent, isn't it? 1 over 5 to the x at 4. Again, same thing. Right, okay. So we're doing good. We're doing good. Okay. Two to the y over 3. Like that. I'm sorry, that's just foolish there. Now check. Okay, that's correct there. That's correct. Correct and correct. Right, the next 4. 5 to the y is 3x cubed. Take x, take 6. So 5 to the y add 6 over 3, cube root. That's equal to x. And then swap the variables. There. And for this one here, divide both sides by 6 and do 2 to the power of both sides. So 2 to the y over 6 equals, beg your pardon, 2 to the x, take 7. Add 7, do log base 2. And swap the variables. Move the 7 over and divide by 6. Log base 5 of negative 4x. 5 to the both sides and then divide by negative 4. So y is negative a quarter of 5 to the y add 7 all over 6. And here, log base 6 of both sides, so log base 6 of y is x over 4. 4 times both sides. And so swapping the variables ahead of time, y equals 4 log base 6 of x. And now to check. Okay, on the 9th one, that's fine. 10th one, correct. 11, did not swap the variables correct. Hold on, that should be an 8. It should be an x. That should be an x. Okay, that's all good. And this here, they wanted you to use that law where you have it there like that, but that's totally fine, equivalent. Next, well, 20, wait. Okay, proceed. What the heck does one do here? Well, you split the fraction into 2. So you notice that that's 5 to the 1 plus x, all divided by 5 to the x. So that's 5 to the 1, or just 5, plus 1 over 5 to the x, which is 5 to the negative x, like that. And now do y take 5 equals 5 to the negative x. And then do log base 5 of both sides. Log base 5 of y take 5 is negative x. So y is negative log base 5 of x take 5. Here, y at 8 equals 5 to the x. Log base 5 of both sides. There. Next. Log base 5 of both sides. So x over 2 equals log base 5 of y. So x is 2 log base 5 of y. And then conclude by swapping the variables. 2 log base 5 of x. This is 1 over 4 to the 1 plus x, which negates the power. And we must now bring the negative over to the other side. Then do log base 4. Log base 4 of negative y is equal to negative 1, take x. And then make that negative to turn those positive. So x is negative log base 4 of negative y. Take 1, and now conclude by swapping the variables. Y equals negative log base 4 of negative x. Take 1. And check. — 13th is not... No, it is right. It is. They've just used a base of a fifth, which is equivalent to having negative in front. Okay, that's correct. And again, they use this law, which I should have recognized because I missed that. That's correct. That's... Wait, what? No, hold on, just a sec. Just a second. Just do it again. No, we don't need to. No. Look. Log base 4 of negative x. That's equivalent to... And then take away 1. Okay, that's equivalent to log base 4 of negative x. Take log base 4 of 4. And then you divide by, and then you have a quarter down there. And so it's actually fine. It's actually fine. The next 4 now. Do not stop until the work is done. Do not stop. Okay. So I'm going to start out by cubing both sides to get rid of this third, 1/3 power there. So y cubed is 4 to the x, all divided by negative 2. And now negative 2 of y cubed is equal to 4 to the x. And now log base 4 of negative 2y cubed is equal to x. Okay, so you swap those around, the variables around rather. So y is equal to log base 4 of negative 2x cubed, which is log base. Well, you can actually split this up. Log base 4 of -2 plus 3 log base 4 of x. Log base 4 of -2 is saying, like, to what power do I have to raise 4 in order to... That doesn't have an answer. What? So I just leave it like that? Excuse me, I'm not sure if I quite fully believe that. Right, we're going to check. We have to check. We have to check. Don't just skip over stuff. That's bad. That's how you get this whole, like removing zeros in the domain, removing just this logically weak business in maths. Y equals 4 to the x over -2. And then all of that to the 1/3. Now, I will put this in Wolfram Alpha, but I don't think it will get it. And the reason why is because basically you have to know Mathematica beforehand. Look, see, it doesn't know. I really, look, Wolfram Alpha is absolutely fantastic. Absolutely fantastic for arbitrary precision arithmetic, so many things. But they really, really, really have to have like a little LLM somehow at the back end. You know? Right, so we're going to use a combination of Gemini and DeepSeek. Right. Write the function. That's what I did. Swap x and y. That's what I did. Cube both sides. That's what I did. Multiply both sides by -2. Good. Apply logarithms of both sides. Good. Okay, I like it. I really like it how at the end they talked about domain consideration. Okay, but essentially they come to the same. All right, so we understand that. Now, to invert the 18th one. And the way that I will do that is I will do 5 to the power of both sides. And then add 1 to both sides. And then take log base 4 of both sides. And then swap the variables. Like that. 19th. Raise both sides to the power of 4. Add 7 to both sides. Log base 5 of both sides and swap the variables. Square both sides. add 2 to both sides. And beg your pardon, log base of a fifth, both sides, and swap the variables. Like that. And now to check. No, the 18th is wrong. Correct it. Oh my goodness me, look at that. All right, so put things in their appropriate spot. So that should be y to the 5, y to the 5. This is beg your pardon, I'm swapping the variables here. That's fine. That's fine. And that is fine. Okay, last 4 here. Raise both sides to the 4. 3 to the x, take 8 all over negative 3. Times both sides by negative 3. Negative 3 y to the 4 equals 3x. 3 to the x, take 8. 3 to the x equals negative 3y to the 4 plus 8. Log base 3 of both sides and swap the variables. Five to the both sides and times both sides by 2, all in one step. 2 times 5 to the y equals 3 to the x, add 9. Take 9 from both sides and log base 3 of both sides. There. Square both sides and multiply both sides by negative 2. So negative 2y squared equals 3 to the x. Take 4. Add 4 to both sides and log base 3 of both sides, and then swap the variables. There. Both sides to the power of 5, both sides times 3. Add 9 to both sides, log 3 of both sides, and swap the variables. So, I mean, this feels a little bit too simple there. Here you can factor out 3. And so what? It would be 1 plus log base 3 of y to the 5 add 3, I guess. Right, but let's sort of come to come to a close here, and let's check. 21. Correct. 22. Didn't swap the variables right. 23. 24. Fine. Okay. Right, that's enough just for now. See you shortly and be well.